My name is Liz, and I'm a rising sophomore at Monte Vista High School. My project is the phone-controlled robot arm, and I chose this project because I'm interested in robot arms. I just finished my modifications, and for my modifications, I decided to add wheels to my robot and to be able to control those wheels so my robot arm is able to move. In order to attach the motors to the chassis, I used double-sided tape on 2 motors and attached wheels to the motors, which was really easy. And then I attached the motor driver to the front of the chassis and attached the wheels to the motor driver. Here are the 4 wires. The yellow wire controls the yellow and the green wire control the left wheel. The yellow wire makes the left wheel go forward. Green wire makes the left wheel go backward. Purple and blue control the right wheel. Purple makes the right wheel go forward, and dark blue makes the wheel go backward. We have more wires here. These wires are for my battery. I decided to plug in the battery to the motor driver and have it supply power to the Nano. I used to plug in a battery directly to the Nano and a battery directly to the motor driver, but it didn't work because they were like 2 different circuits, so they weren't really communicating with one another. So I just decided to use one battery and wire over the power to the Nano using this orange wire, and this gray wire. The gray is ground and red is power. So you might have noticed I only have 2 wheels because my third wheel is a swivelly thing. It's like the bottom of a shopping cart, like one of those wheels that can turn in any direction. Now you might have noticed that the swivelly thing is like very short and the wheel is kind of tall. So if it weren't for this piece, it would be very slanted and it wouldn't work that well. So I designed this piece on Onshape and had it 3D printed. I had to measure all the parts. Like I had to measure the height of the wheel. I had to measure the height width of the swivelly thing. I had to measure the width of the holes, and it actually took way longer than I expected. Like it took a full day to just measure everything. So I'm very glad that I'm over with that. And I also decided to make my wheels controllable by the app because I considered having it being controlled by like a wired controller, but then you would have to like walk along next to the robot, which makes it very inconvenient. And in my code, I already integrated the Bluetooth module into like the Nano, so I thought it would just be fairly simple to just use the Bluetooth module for my wheels. So in the bottom of the app, I have these 5 buttons: forward, left, right, backwards, and stop. Usually the wheels should stop by themselves, but I have a button there in case it doesn't, so I can stop it without running down the battery too much. So how the buttons work is when I press down, it sends a signal to the Bluetooth. It sends a signal to the Bluetooth module that says like run. And then when I stop pressing it, it sends a signal to the Bluetooth module that says stop. So that's how the wheels work. For me, the biggest challenge I faced while working on this was definitely wiring up the pins, because I didn't know where and how to do it. Different sources said different things, so I had a lot of trouble trying to wire things up and make it run. Because I read somewhere that analog pins can work as digital pins. So originally I wired up all of the wires onto the analog portion of the Nano, and of course nothing worked, because with some more research I found out that for Nanos, analog pins don't act as digital pins. So that cost me a lot of time. But overall, I'm really proud of and happy of all the progress I made at Milestone Engineering. Before starting this, I would have never have imagined I would actually finish the project. I didn't think I would be able to, and I've learned so much about soldering, how servos and motors work, even about CADing. So I'm really happy with my experience at Milestone.